Okay, we're returning to this 1969 Mercedes 280 with the brand new engine, brand new air conditioning system, original condenser from 1969, original evaporator from 1969. Everything else has been changed. Custom modifications to make up new hoses because the York compressor has been changed over to a SANDEN. So they had to weld on to the original adapters the brand new hoses, and they're brazed on. These are aluminum, done by one of the last and only quality air conditioning shops left in probably about a 50-mile location of the San Francisco area. Over my last 30 years, I've a little over 24 specialty air conditioning shops have all closed doors. We've got one left, and he's left because he's the best. Other than that, what you can see is I disconnected the 8 CFM field piece vacuum pump, and now I only have the NavVac 3 micron 12 CFM vacuum pump hooked up. We have pulled down to 74 microns, which is really good. I didn't expect that. Found out this system and this rebuild and restore has been going on for 3 years. The system has been open to the atmosphere. And so what I have already done, just to check, was I turned off the vacuum port to the vacuum pump, and the microns come up to 376 microns. That's excellent. That means moisture removal is almost complete. Actually, that's above regular standards. High pressure nitrogen, dry nitrogen, a little over 2,000 psi. I have it set to roughly 150 psi. This is what I'll be doing the dry nitrogen pressure decay test with. So here we go. We're going to turn off the vacuum pump. Now, this is important. Pay attention, because we're going to sweep the system at the same time. Use this pressure test as part of the triple evacuation and nitrogen purge procedure to help get more moisture out of the system. Nitrogen itself does not get rid of moisture. It's the sweeping action that does, and drawing down to the low vacuum. So you turn down the low side gauge, that is closed off. If you remember from AC 101, your compressor is 1/2 of the refrigerant system. It's literally internally blocked with the valving. The low side half does not come in contact with the high side half. When you push something in the low side half, it does not come out the high side. When you go down the high side, it does not come out the low side, theoretically. The other is your expansion valve under the dash, is your cutoff point. So in this case, we will be taking the high pressure nitrogen, will be sweeping through, going through this valve, through the manifold. The low side is shut off. The nitrogen will be flowing down the high side hose. It'll go into the high side fitting. Now on this particular vehicle, we're really lucky because it's actually located at the compressor. Some of them are located in the liquid line going by the expansion valve. So you kind of would have a two-way flow going towards the expansion valve and going back to the condenser, through the receiver dryer, back to the receiver dryer, and then back up to the compressor. But this is the optimal, best way when you're so lucky. So our nitrogen will go into the high side valve. It will not go through the compressor and come out the low side. It will go like its normal flow. Refrigerant is being injected out of the compressor. Well, in this case, we have nitrogen going in place of refrigerant. It will be sweeping and flowing through the high side discharge gas line. That's your hot gas, which will come at this fitting right at top of the condenser. Now, this is a tube and fin condenser. I talked about this in my parallel flow condenser video. This one is an indication of a parallel flow tube and fin serpentine type flow condenser. So you have our hot discharge gas coming in right here. and it's going into two parallel 3/8 inch size condenser lines. There's one in the back here and one in the front. This divides up into two, and they're literally traveling, and they're making a bend, and it's coming back this way, and it's making a bend. So you have two pipes, 1, 2, and it's just like a snake. That's why they call it serpentine. And it goes like this all the way down. And then at the very bottom, right here, I'm sorry I didn't have my light on, but this is where they come out and they connect together as two into one tiny manifold, just like up here at the top. It's one, and it's connecting into two to one tiny manifold to go start at the top. It's doing the exact same thing at the bottom. And then there's one line that you can't see back here in the shadow that's coming up between the two rows of serpentine connected tubes. But if you follow my finger, it's coming up here. Then it's coming to this fitting right here. You see this fitting? And this fitting attaches to the receiver dryer. Now this is supposedly almost a liquid, and it's coming as a liquid gas combination into the receiver dryer. It's falling into the top of this tank, and in this tank, in the middle, there's a metal plate, a screen with holes in it, and a screen and a filter pad. And then just below that is the desiccant BBs. And then there's another filter pad and another metal screen with holes in it with a screen. And then that refrigerant that is semi-liquid that contains oil goes through the filter pad, through the desiccant material, and out through the other screen at the other side, drops into this lower portion of the receiver. Now at the lower portion of this receiver, there's a straw that goes all the way down to the bottom, and this fills up with liquid. And that straw picks up the high pressure refrigerant. In this case, it's dry nitrogen that's going to be sweeping back up through the straw, and it comes out to this liquid line, and at this point it's almost a pure liquid. Theoretically, in ideal conditions, it would be. And that straw actually happens to come up right where the sight glass is. That is your liquid pickup. That's actually a straw going to the bottom of the receiver. From here, you're supposedly pure liquid with no bubbles in ideal world, which doesn't always exist. So do not charge by the no bubble situation. We'll feed what's down, called now the liquid line, high side discharge liquid line. From here, we follow that down all the way back, and we're coming all the way back to where it's going to go through the dash to the expansion valve. This is theoretically supposed to be a pure column of bubble-free liquid in an ideal world. Okay, from there, our dry nitrogen will go through the expansion valve and then go through the serpentine evaporator back and forth. All the time, this dry nitrogen is helping push and flush away any moisture that has come to the surface of the metal, the rubber hoses, and push it forward, and it'll come back out of the evaporator. It's going to travel down the low side line, come all the way back the low side suction. That's a suction line. Here's the suction line coming back here. Then we're going to purge off the nitrogen out of the low side. When we do that purge, we will close off the high side because we don't want to purge backwards. We want to purge in one direction. So at that point, we will be shutting the high side, opening the low side, and then bleed off and purge out our nitrogen to the atmosphere afterwards. And we'll perform this task 3 times, but right now we're just dwelling on a pressure test. So here we go. Closed, 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 open. Now let's add some pressure. And I can hear the pressure going in, going up, and I think I hear a leak. Oh yeah, we got leakage. Now you see how deep of a vacuum this system held, but yet it's leaking under pressure. There we go, at rubber, at the crimp. So this shows you that you can pull and hold a deep vacuum and actually pass a test, but leak under pressure. Because pressure and vacuum are two different things. Rubber can pull inwards on the metal clamp and seal itself. And the difference between atmosphere and vacuum is only 14.7 psi. But the difference between pressure in the other direction, I have 111 psi. And as you can hear, we are leaking like a sieve. So that's the end of this journey for today. It will be sent back for repairs. The hose will be redone, and I'll come back another day. Part 2, wait for part 3.